Good morning, students. Welcome to online class. I hope your history is going smoothly. So today we will start what is compound event. Okay, compound event. An event which is not a simple event that is called compound event. Okay, a sim an event which is which is not single called compound or composite event. Okay, or in place of not single we can write not simple. Okay, not simple we can also write. So an event which is not simple called compound or composite event, and a second mutually exclusive events. Mutually exclusive events. Two events are said to be mutually exclusive event if their intersection is equal to phi. Okay, two events are said to be mutually exclusive event if we take their intersection and no common element we can find, then we can say that both events are mutually exclusive events. Okay, then two events E1 and E2 are said to be mutually exclusive event if E1 intersection E2 equal to phi. Okay, for example, for example, let us consider we throw a die. Okay, then what will be the sample space? It will be 1 2 3 4 5 6. Okay, and consider two event consider two event which is subset of S. Okay, two events E1 and E2 which is subset of S. Okay, such that such that even even equal to event getting number less than 4. It means equal to what? Even equal to what? 1, 2, 3. Okay, less than 4. And it will be an event. It will be an event getting number more than 4. Okay, then clearly it will equal to what? More than 4 means 5, 6. Okay, so whenever we find even intersection E2, it will be 1, 2, 3, intersection 4, 5 and 6. So we find even intersection E2 equal to 5, because no element are going to be common. So in this case we can say that E1 and E2 both are mutually exclusive events. Okay, now next, mutually exclusive and exhaustive events. Mutually exclusive and exhaustive events. Mutually exclusive and exhaustive events or system of event. Let E1, E2 up to so on En be the subset of a sample space N. Then we can say that the event E1, E2 up to so on En form a mutually exclusive and exhaustive system if EI intersection EJ is not equal to 5 for I is not equal to J, and E1 union E2 union E3 up to so on union En equal to yes. Okay, then write, let E1 E2 up to so on En be the subset of S, then E1, E2 up to so on En form form mutually exclusive and exhaustive system if EI intersection EJ is not equal to phi. This is first one, and second, E1 intersection E2 intersection. Okay, if we take union, okay, here union E3 up to so on union E n, then we get whole sample space. Okay, let E1, E2 up to so on En be the subset of S, then E1, E2 up to so on En form mutually exclusive and exhaustive system if EI intersection EJ is not equal to phi, and E1 union E2 union E3 up to so on up to union En equal to, we get whole sample space. Okay, that is S. Next up is independent event. Two events E1 and E2 are said to be independent event if the occurrence of first doesn't affect the occurrence of second. If the occurrence of two event E1 and E2 are said to be independent events if the occurrence of first doesn't affect the occurrence of second. Okay, then E1 and E2 are said to be independent event. Two events E1 and E2 are said to be independent then if the occurrence of first means E1 does not affect the occurrence of E2 at second. Okay, two events E1 and E2 are said to be independent if the occurrence of E1 does not affect the occurrence of E2. For example, suppose we tossed two unbiased coin and let E1 be the event of getting E1 be the event of getting head on first coin, and let it to be the event of getting tail on second coin, then we can say that E1 and E2 both are independent events. Next, Equally likely event. Equally likely event. A given number of events are said to be equally likely if none of them is expected to occur in preference to the others. Okay? Equally likely means equal opportunity to come the given event. Okay? That one is called equally likely event. Okay? Thank you for watching.